Before we start this actual talk, I also like to welcome you here. For those of you who don't know me yet, my name is Collin. I work for G-Data, that's an antivirus company located here in Bochum, and we are offering additional evening events. Basically, every time when we have an invited speaker here, this offer exists. Here you can see some of the facts. Basically, what will it be? We will go over there directly after the talks. Around 7 we start with a nice dinner, and the basic idea of this event is that you have the possibility to speak a little bit more in detail with the speaker about the topics he's presenting today, or if you just want to get in touch with people working in the antivirus industry, especially if you want to talk to people from the technical part, all of you are welcome. And yeah, I think it's a really nice possibility in a cozy atmosphere to get in touch a little bit more and to ask questions that are out of scope after the talk. Basically, if you have more questions, come to me after the talk and I can explain it a little bit more in detail. And now let's welcome our speaker of today, Collin.
Yeah, thank you for the introduction. So, my talk, as you saw in the announcement, is about security of graphical user interfaces. The talk is basically from a paper we had this year at Security and Privacy, and that was joint work with the two professors I work with, William Robertson and Engin Kirda. And yeah, I work basically as a postdoc at Northeastern in Boston. I mostly do like system security, with like a strong focus on operating systems, general software security, and really doing offensive and defensive research. And I used to do a lot of mobile phone research, but at the moment I'm more focused towards like classical desktop server things. And some of the material I'm presenting can be downloaded from my website. Just like some tools I'm recreated, and of course slides. But I think the slides are also going to be available through the seminar. Okay. So graphical user interfaces, I guess I don't have to talk much about it, but it's basically the de facto standard if you like use any kind of computing device today, no matter if it's like a desktop or a smartphone or some computer-based appliance. For example, even like medical devices like EEGs or EKGs are basically just like Windows desktops with like some extra stuff, and you have UIs everywhere. So I'm first going to tell you a little bit of background about UI security and some basics of UIs, access control in UIs, and then the kind of attacks we looked into, and then a way to automatically find those kinds of bugs and how to exploit them, and a little bit about countermeasures, and I will have a lot of demos. So if you look a little bit back into the history of UI security, there's basically one big incident, and that was around 2002, 2003 with the shatter attacks. I don't know if anybody heard of them, but it's affected Windows NT 2000 XP, so that generation of desktops or Windows versions. And the idea was you manipulate the UI, for example, text entry fields to like say, okay, the application had this like 20 bytes input limit, but you could just remotely, like from outside the application, just tell the UI, okay, this is like unlimited input now, and then you could paste a large amount of data into the text field, and you would just cause normal memory corruption. That way you could get code execution. And the target was processes that were running with system privileges. I think even so some antivirus products were also vulnerable to that. And by that, a program could basically get privilege escalation, or you could abuse those bugs to get privilege escalation. And then you could get administrator rights, for example, on any of those systems. And this was a really fundamental flaw in in the UI concept of that Windows versions, because unprivileged process could manipulate the UI of privileged processes. And Microsoft changed their UI subsystem completely and introduced this user interface privilege isolation, so that you cannot manipulate the UI anymore of processes that are like run with higher privileges. It's basically you can't send like an IPC message to a process running with a higher privilege. Like the same, you cannot just kill a process on a Unix system that runs as root if you're not root. But this talk is not about this. This is basically a really was an old issue, and this talk is more about access control within applications. So if we go back and look at UIs again, what's a UI? Basically, UI, you have a bunch of windows and widgets. And normally, you have the widget is like really the base element, so the smallest element in a UI framework. On a Microsoft Windows, a widget is basically called a window. Really surprising, I guess. So that's like the smallest form, and you have common widgets, which everybody know, like a window or just a frame, a button, checkboxes, sliders, all those different things. And with all of those widgets, you like compose your windows and your application. So each window or widget basically has some basic attributes, because you want to change the windows or widgets at runtime, so have like a more dynamic UI. So sometimes you want to like enable or disable a widget, or hide a widget and on some conditions, or maybe change the read-write attributes. So you cannot change like the data that is stored in a widget. And that's just implemented so you can do like have really dynamic UI. So for example, you have a login window of your OS or some application. And why would you want to disable a button? You want to disable it so you can like give the user feedback to say, hey, first you have to like enter a username, and then as soon as the username is entered, maybe the login button is already activated. So just to indicate, hey, you have to do something in order to like pass a step. Is really just to make programs more accessible without having to like read documentation or things like that. So now let's take a brief look at access control. And access control is really one of the basic security requirements we have today. It's really common in any kind of enterprise application. You have some data and some users in an application, and some users can read it or write it, create new data, modify data. So it's really, that's one of the big requirements. And especially if you have, applications that like handle a lot of sensitive data, you want to have access controls with different levels. And in some cases, people might want to implement access control in the UI because it's just very tempting. It's like you can like just manipulate the UI in a certain way, and then the user doesn't see certain data or is not able to modify certain data. So this is very tempting. So if you take a look at a very simple application, you see there's a disabled button down here. There's a user down here. So so this button might be used for access control to a certain functionality. In this case, this is just like a very simple inventory management application. So this might be used for access control. So if we can manipulate widgets, since we can manipulate widgets, since it's like a really basic feature of in a UI framework, we can basically have access control bypass. So every time we can manipulate a widget, we can bypass maybe bypass some access control. And the nice thing is this feature is really like inside the UI framework, so you don't need to like modify the binary, because of course you can just like reverse engineer the binary and patch certain things out, but for that you also like need a specific skill, and this also takes some time. And as you will see, UI manipulation attacks are really more interesting. Just a very easy startup demo. So with this application, and so normally I would have to log in. So, but I don't know it. So, but maybe this application is vulnerable to UI attacks. Let's have the quick demo, and yeah, so we can just like manipulate the UI and just like get to the central user database by just flicking a switch on the visibility of some widgets in Windows. So very, very easy. And now I'm going to show you like how we found this and how you can find this stuff. So attacks on the UI have been people have known that you can like do manipulations on the UI, and then you can maybe gain some features of some applications or bypass some stuff, but it's like not really, nobody really investigated it before and like did like a targeted study on applications to see like what kind of attacks or what kind of bugs exist in applications and how easy it is to like actually exploit those. And as you will see later, it's very easy. My claim is like some bugs are so easy to exploit that I will exploit them before you even find where the binary is stored on disk. Okay, the contributions of our research, basically we introduced like a new bug class which we call UI element misuse, or short GEM bugs, which is we say a novel class of security vulnerability, and it's really like misusing the UI or UI elements to implement access control. We define 3 classes of GEMs, they being like information disclosure, so you can get data which you should not get, being able to modify data, and also like execute functionality you shouldn't be able to execute. And we developed this tool we call Gem Miner, basically to automatically analyze applications to find gem bugs. And this completely works completely black box, so we don't need source code. We also don't need to like reverse engineer the application. And then we like tested our tool against a bunch of Windows applications, and also found a bunch of bugs in commercial and like shareware kind of software. And also we released some tools. So what is the threat model? It's basically applications that have internal user management. So and the application normally needs to have like multiple users and also multiple user levels, so with different privileges. And those user accounts or accounts should not be backed by the operating system. As soon as the operating system comes into play, you just have normal operating system user separation. But a lot of applications, one very simple example, for example, like SAP, where you don't have OS users but application users, or like any other multi-user application. And the accounts should have different user privileges. So for example, like reading data versus writing data, executing privileged functionality. And most of the applications are probably enterprise applications, because there's where you like have most of those issues where you want to have separate users being able to do different things and having access to different functionality in data. So, and partially also, or most of the attacks will like kind of boil down to maybe insider threats, where you have like people in in a company having like restricted accounts to maybe their like some internal software. For example, if you like think about like some maybe employee management thing, and you have people who just like maybe press buttons to pay bills, but if they would be in a different privilege level, they could just like look at the salary. So if you could just like do some magic to the UI and see salaries of employees, that would be bad, and probably a lot of people would have an incentive to see that just because it's interesting. Just some examples. So, okay. So UI element misuse or GEM vulnerabilities is really misusing UI elements to implement access control, and a GEM vulnerability is an access control bypass vulnerability. So if you're familiar with like different vulnerability classes, access bypass is probably very, very well known. And yeah, the three classes we more or less defined is like unauthorized callback execution. So basically we are able to like run a piece of or execute a piece of code within the application which you normally should not be able to trigger. Then yeah, unauthorized access to data and unauthorized manipulation of data. So callback execution. So normally in an application, maybe you activate a UI element, for example, by clicking on a button. And that button normally executes a callback, and that performs some operation on the inside of the application. And here the assumption from the developer is, okay, if we disable this UI element, the user with this specific user cannot click on the button and execute this functionality. And the idea, the attack, would be we re-enable the UI element, interact with it, for example, click on it, and then we can execute this callback and perform a specific operation. I have another small demo, and this is still based on a tool we just used, which somebody else wrote, called WinSpy, basically UI manipulation software. But we also modified it a little bit for certain other features. So if we go back, we first have to log in, since we know the password was, I think. Now we can just quickly look it up. 1, 2, 3, 4, 5. Yeah. Then we have this, just some really, there's some application, and you see this is, just have to trust me, I'm really clicking it and nothing is happening. So we can use a tool like this. Later we'll show you some other features of this tool. So you basically can just go through the whole UI. And you can already see this button. Let's see, let's go to here. So if you can press refresh, you see this is this button. So now we can just say enable, and now we can just click on the, you also see and then we can just say test article. So I have this nice thing. So that was not too hard, right? Reversing the application to change some flag would probably be harder. More on all of this stuff later. So if we now look at unauthorized information disclosure, basically you already saw the demo in the beginning. The idea is you have some data that is stored within your application, and only a privileged user should be able to see it. So the developer just says, if I create all this stuff, all these windows, and put the data, and then I just hide it, and as soon as a user logs in who has the privileges, I just flip the flag, and the UI draws the window, and then the user can interact with it. And the attack is obvious. You just go and flip the switch to set all widgets to be visible, and then the UI framework will say, hey, this is visible now. It will just draw everything, and then you have access to the data by either looking at it, or by you can also programmatically just access the data that is stored in the window and just dump it. So we built this tool, which also used in the beginning, and we have some additions to this tool. So let's start this application again. So let's see. People, this is not Linux. We don't need this. So basically, so what we do, this tool basically will show us all of the application's UI. Just give it the name of the executable, and then this will happen. And often applications don't survive that, so we just kill it. But now how do we get to all the UI? The tool also dumps all the screens as PNGs. And you also see the name of the actual widget, and now you can just easily look at the application or at everything that is was hidden from you. So those all those things, those are actually not bugs. It's the UI, like all the applications, they create UI elements which they hide and then just like use in some widget and by just moving it to some widgets. So this is to some windows. So this is very normal to also have some of those. And then you have like just normal windows. This looks interesting. And then you just have basically whole UI and like interesting stuff like this where you just say, hey, oh, isn't this the user database? so now you can just like go through the UI and see everything that was created by the application at some point. And it's very to just go through the whole UI without like sitting in front of the application and clicking a button or new window, click a new button, and you just say, and just like look at all of the stuff. Of course, if the application didn't create a specific window yet, you wouldn't see it, but for a very easy overview to see if an application is doing stupid things before, like hiding some stuff from you. Oh yeah, I forgot to change this one. This is already released. So the idea is to just like, you can just give it the name of the process and then the tool will just go and dump all windows. And of course, if you just see one window in front of you and the dump also contains only like one window, then you would see, okay, maybe there's nothing hidden. But you could also see maybe a window where it's exactly the same window, but you see, hey, why is there like buttons all over the place? Because maybe there was a bunch of widgets in the current screen that were like hidden, and the tool will just go recursive through like windows and like find everything for you and just like make screenshots. So the same kind of bug, or the same bug has like another incarnation, and that is when an application does not like remove information from memory or widgets from the screen when, for example, a user switches a role. For example, you have some application, maybe some data entry application. You enter some data, you make a mistake, and then you have to call maybe your supervisor to like, and the supervisor enters a password, changes the data for you, then logs back out of the application, or like just like goes back to the normal user. And then maybe there's something still stored in the application or in the UI, because the application will say, oh, I will just hide the screen, hide the text field where somebody entered a password, and the attack is exactly the same. You just go after the fact and then while the application is still running and see if anything changed and if you can still access that. I also have a demo for that, but I will do that at the end. But it's very, very similar to the other stuff. What becomes a little bit more interesting is if you look at unauthorized data modification. Because data, like accessing data is one thing, but if you're like able to modify some data without having authorization, can be a little bit more problematic. And the idea is, for example, you have a text edit field, and a privileged user like can edit data, and an unprivileged user can just see what's stored in the field. And the developer makes the assumption, okay, if I just set read only to this UI element, the user cannot modify it. And apparently some applications, what they do, they load all the data into like a form, for example, show it to you. And then if the user presses OK, they just like dump everything back because they assume, okay, everything that the user is able to change was stored, and everything that the user is not able to change will just be the same. And the idea is, okay, we can just change the UI element to be read-write, or we can just directly sometimes change the data, click Save, and we're good. For now, I will only show you an easy way to actually look at how you can determine something like this. So we have another application which unfortunately does not, where we cannot access the user database, but I think I actually know the password, yes. So let's see, just some screen that the content doesn't. So the same application, but now I will show you some slight modifications we made. There we go. Windows software. Yeah, the resolution. There we go. So now we can do this. Okay, this was not. Let me restart that. Otherwise, you don't see anything. Go away application. So. Yeah, the screen is a little bit too small to have everything. So. So, flash. It's not the right one. No, that should be the right one. No, come on. Oh, okay, no. The magic was to press refresh. So there we go. Yeah. Oh, come on. Okay. Yes. Small screen. So there we go. Okay, so basically this analyzes the UI of this exact window, and it colors every field that has read-only permissions set to it with a red border, which totally makes sense because this is like the name of the field and there's some data in it. So this user basically can only look at all the data, but it cannot edit anything. So the user, I can click here, but yeah, nothing changes. Yeah, I cannot edit anything. So. And we could log in as a different user and see there is some different settings. But yeah, I won't go to the same screen again and do the exact same thing. But basically, you can log into the application with two different users with like high and low privileges. And you see the user with low privileges has all his fields set to read only, and the user with high privileges has everything set to read and write. So this probably gives you a very good indication of, hey, this application could do something funky with the widget privilege, the widget settings, but also it couldn't. But this is a really good and very fast way to find out what the UI, how the UI just looks like. And this tool basically just goes and does a live analysis of the current screen and just like draws an overlay on the application. Then you can just like take a screenshot. So if we now look a little bit at the technical side, so all the applications have to be executed as the same OS user as, like, for example, this our attack tools, because you basically send IPC messages to those applications, and we basically need to be able to do 3 steps. Basically, we have to be able to discover UI elements. So basically, we have to be able to ask the UI framework, hey, can you give me a list of all widgets that are currently registered for a process or maybe in global. And then we must be able to like obtain a handle for a widget and be able to like manipulate or get information from that widget. And if you have these 3 capabilities, you can launch this kind of attacks. On Windows, this is really a very small set of APIs, which is all very well documented. It's basically you can just use calls like enum child windows, where you can just say, okay, give me all of the windows that are owned by this PID. And then you can like query information like, is this window enabled, is it visible, what's the position, or you can send input to the application or to the widget specifically. Yeah. So if we now look one bit deeper. So on Microsoft Windows, basically a window, as I said in the beginning, is the basic UI element. Everything is a window. A button is a window. A checkbox is a window. And the Win32 API provides this basic functionality where you have like an actual window or a button or a text field. And this is like really, really basic. But other UI frameworks are like based on the Win32 API, for example, Dotnet. Dotnet would use the underlying Win32 window concept and, like, for example, have their own implementation for drawing a widget or for implementing how input is sent to the widget or received from the application by the widget. So on .NET, .NET is basically a Win32 Windows plus a bunch of custom widgets. They implement all their own functionality, but you can still use the Win32 API to manipulate and, for example, or enumerate .NET windows. For an attacker, basically the attacker just needs to be able to do the enumeration and doesn't really need to know anything about if an application is a .NET or a native application. Sometimes you will see something like this, which you would say, hey, each one is a button, but this is like a .NET button bar, so everything is every single icon is its own button. But for the Win32 application or for the Win32 API, this just looks as one button. So if you want to do more more specific or more targeted interaction with like this kind of elements, you would need to like include like a .NET layer into your attack tool, but mostly you don't really need it, because in the worst case you can just say, instead of saying, hey, this button was clicked, you can just say there was a click, stupid laser pointer, a button was clicked at this and this coordinate. So if you like see this, you can just say, okay, we can just like click here. But this part is really more of interest for the automation part, which I'm going to show you next, or very soon. Yeah. So, and before we look into the automation, let's recap a little bit about gem vulnerabilities in general. There are like really two cornerstones, and the first one is like there is like a lot of false assumption by developers. Developers think, okay, the UI cannot really be changed. The widget status, if it's like hidden or read-only, that's really protected by the framework. So we can use those things to like implement, for example, access control or maybe even just access control-like features. And on the attacker side, the attacker doesn't really need to be sophisticated. If the attacker knows how to operate a UI application, that he can like point at something, click at something, an attacker can really, with knowledge like how those attacks work, can very easily understand and attack applications. And the attacker can really be, can like attack like basically the application as a black box. Because the attacker basically needs to know, hey, there's this button, it's not enabled. I want to click on this button, so let's enable this button and click it, or I want to like modify this field, and the attacker just like modifies the field. So there's no reverse engineering involved, so no program understanding. You don't need to like manual tamper with a file or a database. Because of an application, if you could just like go to the file and manipulate the file, but for that you need to understand the format, is there a checksum, and so on. But if you can just like abuse the UI and tell the application to do something different, or something that you normally shouldn't be able to do, the attack becomes much easier. I would say the attack is really that easy that like really completely unskilled people can do that, and also the attack can be potentially very fast if your screen is a little bit bigger and you don't have to have two application screens next to each other and not overlapping. So finding all of this, like this kind of bugs, is a lot of fun if you do it for the first time and you sit in front of your application and click around with one tool where you can like highlight stuff, or like, hey, can I enable this button? And then you find out, oh, if I enable this button, there's some other internal security feature of the application which says like, no, you don't have the privileges, even you click the button. So our idea was let's build a completely automated tool so we can really systematically analyze applications for this kind of vulnerabilities. And also, yeah, if the application is super complex, it will just be hard and tedious, and maybe you like click through like, I don't know, 50 menus and 40 buttons in a screen, and maybe you miss one with your manual testing, and then you think, oh, there's nothing, but there's actually something. So you really want to have an automated tool to like test these kind of things, because then you can just start it and I know surf or read something else while the tool like analyzes the application for you. And our goal was to like build a completely black box, so we don't so that we don't require source code access or reverse engineering. So that was the goal. So the idea was our tool first explores the application's UI, and then we just record the widgets, like what widgets do we see, what are the attributes, is a widget hidden, does it have read or write flags, and while doing this the exploration, then we try to identify candidate widgets, so widgets that have the potential to be be a gem bug, and which could be abused later. And then we actually also do full checking. So we actually try to automatically exploit candidates. And if we see, hey, we can actually use the manipulation to like gain more privileges, we know, okay, this like UI widget or this widget is really a gem and can be abused by an attacker. So before you, of course, do automated testing for this kind of applications, you really need to do some seeding, because if you don't, normally when you install an application, it doesn't have like an administrator and 5 different user levels. So you have to like create users with different privilege levels, maybe insert some data into the application, because if you're looking for leaks, you have to have some data, because otherwise you like see, okay, I can see this window, oh, there's no data in there, oh, there's no data in there, because there's no data in the database, you wouldn't see anything. So you have to do some seeding, which is of course manual, and also you have to figure out, okay, how do I tell our tool to log into the applications, which is basically just say, if you see this window, enter this as a username, this as a password, and the rest is then automated. But you have to do this very basic seeding. And yeah, of course, you have to configure access control, so you have to restrict privileges of at least one account. So you have like an account with no privileges, an account with like high privileges, because you have to have the difference. If you only have like 2 administrator accounts, yeah, they likely are able to see anything. For the UI exploration, basically our application goes and interacts with all widgets on a screen. It remembers which widgets it interacted with. If there's a new window opening, for example, it will do the same, and will go recursive through the whole application until it determines, okay, I cannot do anything anymore. And it would like click buttons, set checkboxes, select drop-downs, and so on. And then while doing that, we record all the attributes, all the widgets, and especially also how we came to a widget. And for that, and this whole process, so this whole automation, which is like looks at one application and for one user, we have to do it for all the different privilege levels. So if you configure an administrator and a normal user, we have to run the whole process twice, because we want to see the different states of the UI in the different privilege levels. And what we call like a UI state is basically say, okay, we have a window, all the contained widgets, and all the attributes of the window on every widget. And then we have a database with candidates and a candidate. So we have, for example, we have like 2 runs of an application. With a low privilege run, this is like a button. This is from the initial demo, where you say, okay, this new article buttons for the low privilege user, the button is visible but disabled. And for the high privileged user, it's visible but enabled. You see, okay, there's some attribute are different, so this goes to the candidate list. Then we go, okay, we see, okay, there's a help button somewhere, and of course, for the low and the high privileged user, both are able to access help, because, and then we have another application for the second demo, where we have like an edit field, and you have like You see the field is visible, it's enabled, but it's set to read only. And for the high privilege user, it's set to enabled and read write, but there's no data there at the moment. So very easy. So we have here 2 candidates, and those are go into this candidate box. And then with the candidates, so a candidate basically is like a widget that likely can be abused, but only likely. We don't really know yet, because maybe it's just enabled because the developer want to give really good feedback to the user, like how he can navigate the application, and they actually have more access control in the back. And the candidate information is the widget, what's the type, is it a button, is it a text field, and the path, which is very important. So because maybe you have to first click on this button, then go see another frame, then click on another button, we have to know the exact path, what we have to do to like get to a certain widget, because we need to replay that later for the testing. And in some cases we want to see like a successor, so maybe we know, hey, this button, if you click on this new screen comes up, or this dialog comes up. So then we also record that, so we know like what is supposed to happen. And then for the testing, we basically automatically again execute the application, and of course we would do that in the low privileged mode because we want to get to the higher privileges, and then basically we drive the application using the recorded path to a specific window which contains our candidate, and then we do manipulation and activation of the widget, and then we just see, hey, what happened? Is it actually a gem or not? And for the testing, we just like made basically different testing strategies for each widget type. So, for example, a button has like of course a different testing procedure than like a text edit field, or like information disclosure. It's just like really every kind of widget and a bug type has like a different testing strategy. But again, all of the testing is completely black box. So we just really manipulate the UI and inspect the UI for results. We don't use any other part of the application. And with that, we can just really do all the automation in the UI and don't really care if the application was, I don't know, written in like is like a native or like a managed code application. And all the tests are also application independent. The tests are like for widget types. So we also don't need application specific knowledge at all. So when you test a callback, for example, then what was the result of the activation? For example, is it a new window or is it a pop-up? That's like the information we are looking for when we are actually testing. For information disclosure, actually we don't need to do like testing because we already get the information during the initial crawl. So for example, if you look at the window in high and low privileged user mode, and you see in the low privileged user mode, there's a hidden field which has some data in it, and we see in the high privileged mode this data is visible, and then we can already know, okay, since it's just invisible in our mode, we can just like set it to visible or directly read out the data, and then we can just directly access it. So how do we actually do the testing for example, a button? Actually, no, a text field in this case, sorry. So for example, we have a screen like this, and we say, okay, all of these maybe are candidates, but we look at how do we test one candidate? Okay, we see this price, how can we actually modify this? So we drive the application, so we click maybe multiple buttons, arrive at this screen. And what we do, we change the field to be readable, writable, and change the value to a test value, and then close the screen. How do we close the screen? Basically, we just have a very simple heuristic where we look for something like save, OK, next, and try to avoid things like cancel or back. If our heuristic fails, we can still like do a full iteration, just like try all combinations of buttons. But yeah, we only implemented that to like have it. We actually never had to use it so far because yeah, you just if you add like button names or like operations that are match the application's language. So if it's if it's set to German or English, you just have to have a few words, and it's very easy. And then we change the value, the tool presses save, and then the window normally goes away, and then we drive the application again to the same window, and then we inspect the field. If there is our test value stored in it, you say okay. Apparently the manipulation worked, the application accepted the data. And what we also do at that point, we completely close the application, so we stop it and just restart it to see if the value is still in there, because the application also could have just be like said, okay, yeah, it accepts it, but doesn't really like commit it to the database or file. And if we see that, yeah, we can say, okay, this candidate is confirmed. And we know by manipulating the UI, we can actually trick the application in accepting value, a value where we normally would not, it normally wouldn't accept the value. Some interesting things about about selecting test values. So with the price, of course, it's obvious you want to have some numbers, but our test tool doesn't, of course, know that this is like a price field. It just sees a text edit field. Maybe you see like some options like, hey, this is a numeric field or not. No matter what we always do, we always use numbers as test values, because even if it's like if you can accept like ASCII or just like normal text and characters, numbers are still normal characters. So if you just put numbers, we are pretty sure we're not like violating some very basic input sanitization. Because yeah, if you just put ABC in a price field, it would of course never show up. But if it's like the product name and we put 1, 2, 3 in the product name would still work. Sometimes also that fails. For example, if you have very sophisticated input checking, we found like one application which had like one field which only accepts GPS coordinates, so latitude, longitude, and would actually do really specific tests on that. So if you would like put, I know, 1, 2, 3, 4, 5.5, it would say, yeah, I don't accept that. So of course you'll have things like that, but then at the end when you're done and the program runs, you can flag the output, say, okay, those fields are confirmed, those are not confirmed, or sometimes you will enter some numbers or some data, and you will see a change. So the original value was maybe 23. After you change, maybe the value is, I don't know, 5,000. Even you like put 4,000, you say, oh, maybe, or maybe other round, like you put 5,000, but at the end it's only 4,000. So maybe the application said, oh, we don't have products over 4,000, over 4,000 euros. So maybe the application has some other checks, and we also check, for example, just if the value changed from the original value that we found, if there was something. And if you see like a change, you can also say, okay, there was like the value changed, but not to our test value. You need to like manually look at maybe this one example. And when the application is done running, you basically get a list of widget types. So hey, button and this screen. If you enable it, you can get to this window, which you would normally not get to, and it will also show you, okay, the path. Where is it exactly? And we'll just like dump a list out for the entire application or all the widget it tested. Yes, no, yes, no, yes, no. And yeah, we looked at a bunch of applications and to look at like different kinds of bugs. Information disclosure, information modification, and callbacks. We see up here like how many candidates we had and how many things we actually found. If you have a bunch of applications, like a very lightweight this inventory management, then we have like this employee and project management application, and then we had this like really big customer relationship management application. This is the one where I showed you the fancy overlay. And the interesting part about this is like those two are Win32, so native code. I think one of them was even written maybe in Delphi. And the other one is really a .NET application, and our tool, and we found bugs, same bugs in all three applications. using one or only one tool. So we really don't care if the underlying code is like managed or unmanaged. We can still, just by operating on the UI level, can automatically find and later also exploit those kinds of bugs. Yeah, and we also found a number of, so this, one example in here. So we found like a bunch of bugs in this application, and what we found, for example, we can just enable the button and then just export the entire user database. But if we actually click on the button or enable the button for the settings, there would be actually an extra pop-up screen say, oh, you're not logged in as the administrator. You cannot use this functionality. So the settings, they protected in the application. Somebody thought, oh, that's like not good. But for like, hey, just like export the entire database, you could still do that. So that's like the kind of cases where like a button can be re-enabled, and you think, hey, we can exploit this. We can exploit this button or this behavior, but there's actually a check afterwards. That's why we need to do the live checking of the actual exploitation to see if you can actually reach certain functionality, because just looking at the settings of a widget is not enough. And then, of course, we have the example from the beginning again. So if you just look at disclosure, you find interesting things like this. We can just say, OK, the application creates all or a lot of windows at startup. And before we even authenticate to the application, we can just like re-enable all the widgets and access, for example, the user database. And we also found in this application that if you really do the switch from user admin back to user, you can just like re-enable this window that has like asked for the password, the admin password, and you see still the password stored in there, because just the application just like said, okay, let's hide the window. Yeah, and the same application what I showed you earlier. So we have a bunch of read-write protected fields, and some fields cannot be changed. For example, the application, even if we change, like on the top, something like here, there's like a unique database ID for this like record, and we cannot change it. If you set this will never be written back to the database. And yeah, some fields like relied on other fields, so this like cross checks which are like harder to find, because you'd say, okay, we change this, but like the change wasn't accepted. And this is like things then you have to like manually look into, but it's easier to like look into like 10 widgets than like, I don't know, 10,000. Because if you like sieve out all the ones that like cannot be used for anything, it makes the whole process much easier. And you see the runtime of the actual checks. It's like here, up there is like yeah. In the good case, it's like under a minute, and in the worst case, it's maybe like 10 minutes. So it's really the actual checking is like super fast. The crawling of the application takes a little bit longer, but it's also all the operations. You don't need to like sit in front of the computer. You just start it and leave and look at the results later. So in summary for the attacks, so we showed that these gem vulnerabilities really exist in commercial software, and you can really easily exploit them even if you're not sophisticated or don't have any like deep knowledge about attacks or reverse engineering. Our tool is basically allows you to systematically look for these kind of vulnerabilities, and it's really independent from the UI framework and application. Of course, this tool is right now only for Windows and not for Linux or Mac OS. But on Windows, as long as it uses a Win32 UI, the basic underlying Win32 UI, you can use a tool. And we can automatically find these bugs with our tool, and then you could then exploit them. We also looked a little bit into other operating systems and other UI toolkits. And the basic, what I also said in the beginning, the basic properties are you need to be able to inspect the UI of an application so that you can say, hey, give me access to every widget, and you must be able to manipulate the widget, and of course without reversing or the application or changing the binary or we did a small really proof of concept for GTK where I just like wrote my own application, and you can just like use LD preload to load a library into the application, and then you can just like use the GTK widget manipulation functions on top. And it's of course a little bit more work than just like sending a message to the process like on Windows, but it's the same. So on Windows you can only send a process that belongs to the same user, so not to like the administrator's process. And on Linux the same. If, for example, if the application is setuid, you can of course not do LD preload into that application. So you basically have the same kind of you require the same kind of access to the application. And yeah, and with that, yeah, we could discover and modify widgets more or less in exactly the same way. Yeah, we also looked briefly into countermeasures. So of course the obvious countermeasure would be that developers should not really rely on the UI framework. So you shouldn't store sensitive information in UI elements and treat stored data that is like stored in the UI more or less as untrusted user input. Yeah, and in the best case, of course, should create and destroy widgets and windows as needed. So it's not like, hey, I might use this user. Maybe the user who logs in next will going to be the administrator, and let's already create the administrator window and put all the users and passwords load them into the UI. This like stuff like that should not be done. One part would be one like more or less quick fix. You could, instead of like hiding a UI element, you could just like remove it from the current screen, because if it's the UI element is not there, you cannot like manipulate it very easy. So it's just like a partial fix, of course. And a really like a hot fix would be you can just like try to run applications. So if you have like a setup, maybe in a company, we say, okay, we know maybe this application is vulnerable to this kind of text. You can just say, okay, when the user starts, every time this application is started like as a different user, and the current user doesn't have like the credentials for that user, but you can still run an application as that user, similar like as SUID basically, because then you cannot just like send messages to the application anymore. But this is like really just a hot fix, because yeah, the application is still vulnerable, just not in the current setup. Yeah, the conclusions of our research, basically, yeah, we found this new and interesting class of UI-based attacks, where people basically misuse the UI to implement access control. We found like those 3 different classes, and yeah, we built like a small system to automatically analyze Windows applications, and we found a number of bugs that nobody was aware of, and also not the companies. Of course, we reported the bugs to the companies was aware of, and I think it's like a first interesting step towards like including the UI into like security testing. And like, yeah, and we only looked at like access control vulnerabilities. Maybe there's like other classes, but that's what we did so far. If we have, how are we in the time? So maybe we can do, no, look at some more demos. Okay, so let's look at this here. So this is an unprivileged user, so if we go here, cannot do anything. We can go way too many. Yeah, so we found this field, and so what we can do here now is like now send a new value. We're just doing this, and then we can just click on this button, and then if we go back, it's still here. And now we can like select it, but no modification. Yeah. Okay, and yeah, we can. There's and it's still here. So do you have another demo? I can also go back to this application. So the admin went to see all functionalities. So do I remember this? Apparently I remember this. Now can we say admin log out? And now you can see refresh. And where's enter admin? And what? Yeah, and so you still have like all the stuff here in the UI. Even though we're like not logged in anymore, but it's basically the same issue. If you have with like other software, for example, if you store cryptographic keys in memory, and then after, if you're done encrypting or decrypting, you should like wipe them because they're still there, and that's basically the same issue. It's just on a very on a much higher level where the developers don't really think about the consequences of just like saying, I just like hide this UI element, or we had other findings where we could also just like go to the administrator mode, look at some data, and then you like log back out, or like drop to the normal user, and then you could just see like still a multi-selector field in the background, and you can just like enable it, and you can just see and scroll through all the data and access everything. So is that the only? Yeah. I think that should already, I think that's more or less it. Looking at more applications would be interesting. This was really a sprint while we did that to get the paper done. That's more or less it. Yeah. If anybody has any questions or other demo requests, but I think I showed you more or less all the interesting demos where I don't have to like search for hours for some specific small UI element. Otherwise, thank you very much.